Our team has worked to build a 2D grid-based fluid dynamics simulator using the Navier-Stokes equations. An additional element which our team has worked on is the ability to dynamically input boundary constraints on our simulation and see how that would impact the fluid behavior. Now I'll share some details about our technical implementation. To start with, we created two buffer textures for each property we wanted to keep track of. For example, here I've created two for velocity. Next, we pass one copy of that texture as the input to a WebGL shader. Here is our shader pipeline. Each shader takes one copy of the texture as an input and uses the other copy of the texture as an output. Each box highlighted in blue is a piece of our pipeline in which we check for the boundary conditions. We write the output of the WebGL shader into the second copy of our texture and swap the two copies. Lastly, we use the copy with our final output to render the scene. Our interactable demo also offers users the opportunity to visualize each texture and piece of the pipeline. For example, here's the density, but I can also see the velocity as well as the vorticity here. Our team really enjoyed working on this project. We found it to be both a fascinating and rewarding experience in transitioning from a mathematical model to a visually striking real-time fluid simulation. In particular, we gained a deeper understanding of shader frameworks with new technologies like WebGL and 3JS, and we were able to witness a real application of the instability of Euler's method.